Visualizing domain and range. Remember, the domain has to do with the x values of a function, while the range has to do with the y values of a function. So one way that we can analyze domain and range is by looking at the graph of whatever function we're talking about. And the range especially, we really need to look at the graph for. Domain, as we've done in a previous example, you usually can do just with the equation. So we have 6 graphs here where we're going to write out the domain and range. And so to represent domain, I'll write a D. And we're going to use interval notation to explain. Now on these graphs, if the like on this case, this line touches the edge, and so we can think about it like it's going to continue both directions. F would be an example where clearly we're not going to continue where these lines stop, but if it goes all the way to the edge of the graph, then think about it like there's arrows there. So our domain for A, the x values it has, well, x is left to right, and so if we think about going to the left, is there ever going to be an x value which we can't get? No, because this is going to keep going down and to the left. Is there any value to the right that we can't get? No, because it's going up and to the right. So our domain is all real numbers, or negative infinity, positive infinity. Our range has to do with the y values. So we look at this up and down and we say, is there ever going to be a y value if we keep going down and down and down? Like, is there going to, like, negative 20 for y, is that still going to have some value on this line? Yes, it is. There isn't any value that it won't work for. So our range is also negative infinity to positive infinity. So that's A. Part B. Remember, if it's going close to the edge, it's like there's arrows here to show that it keeps going. And so for both our domain and our range, we're looking at basically there's something going on right here and right here. We call this situation a situation where we have asymptotes. An asymptote is like an invisible line that your graph gets closer and closer to without crossing. And so we've got a vertical asymptote here. It looks like at -4. And if we look back at our equation and we think about what we did in an earlier example, is we set the bottom equal to 0 and we solve, and sure enough we get -4. So in interval notation, our domain is that we're going to go from negative infinity to -4, and then from -4 to positive infinity. And when we write it like that with the u and the separate parentheses, remember we're saying only -4 is a problem because it has parentheses and not brackets around -4. Our range then is going to be similar. We just have to figure out now what is our horizontal asymptote, and we haven't talked about how to find horizontal asymptotes from an equation, but you can pretty easily hopefully see that 0 is where our horizontal asymptote is. So for our y values, we'll have like a y value of -5. Hey, that's right here on the graph. We can have like -2 that's here on the graph. But the closer and closer and closer we try to get to 0, it will never actually get a y value of 0. And so that means that we have to exclude that from our range. Now, on these problems, the other way besides interval notation that you can write this stuff is using an inequality kind of notation. And so if we want to do that, our domain, for example, we would use the squiggly brackets in our x, and then we could say after this line, we could say x does not equal -4. And all this is saying is that we're talking about our x, and our x can be anything except -4. And so then for our range, we would put a y, because we're talking about our y's, and then we would say y does not equal 0. Part C. So now we've got a square root function. So it does keep going to the right, but it starts right here. And so what matters is that what is this point? It's going to matter for our domain and our range. So it looks to me like that point is 3, 0. So what that means for our domain, because remember our domain is x and goes from left to right, is that we don't have any x values until we get to this x value of 3. So our domain is from 3 to positive infinity, and we would put a bracket around the 3. The reason we do that is our function actually is equal at 3. It can be 3. You can plug in a 3 here, you get the square root of 0, which is 0. Okay? We can't plug in anything smaller than 3, like 2.5, because then we end up with a negative under our square root. Our range, going from bottom to top here, and thinking about what are the y values that work. We don't have any y values until we get to 0, and then our graph goes up and to the right, which means that every y value bigger than 0 will work. So we do 0 in a bracket, comma, infinity. You may wonder, why are we putting parentheses around infinity? Well, we always put parentheses around infinity in interval notation. The brackets have to do with it being equal to whatever number we're talking about. We technically can't ever equal infinity because it's more of an idea than an actual number. It's the idea of the biggest thing that's possible to get. D. So our graph keeps going up and to the left, up and to the right. Our domain, if you think about it, since we can keep going to the left, now it's going to go up very quickly in both directions, but we still will be able to plug in whatever numbers we want to for x. So our domain is all real numbers, or negative infinity to positive infinity. Our range, we need to think about from top to bottom, or bottom to top, what y values do we have. And so this right here is what's important, because our graph doesn't go below these two little humps down here. And so that looks like a y value of -7. And so our range it starts at -7 and then it goes up forever. So -7, comma, infinity. And when you're looking back at notes on something like this, you might pay attention then to what the equation is. Notice how we didn't have a square root, we didn't have a fraction, so we easily knew what that our domain would be all real numbers, but our range is more tricky. It really is necessary to look at the graph of that to be able to figure out what the range is. Here on E, we've got a cubic function, and since this would keep going in both directions, our domain is all real numbers and our range is all real numbers. So even though we've got these turns here, we still end up with all of our x values being accounted for, all of our y values being accounted for. And F. Now this equation looks pretty complicated, and basically it's the equation for a semicircle. In order to have a circle, if you think about functions, this is a function because it passes the vertical line test, and a circle would not. A circle, you would have to just have another equation exactly like this that had a negative in front of the square root, but that's not what we're doing right now. So we're trying to find the domain, which is the x values. And so if I look at this, the farthest value I have to the left is at -1. The farthest value I have to the right is 5. It touches and is equal at both of those places. So we go bracket -1, bracket 5. And then our range is that we would start here at the bottom at a y value of 0, and go up to where the top of our circle touches, which is at 3, and so our range goes from 0 to 3. The really important thing to deal with domain and range, besides just remembering how to do it, is pay attention to how your teacher writes it, because maybe they don't like interval notation, which is what I've used. Maybe they like using inequalities better. So make sure you practice doing it the way that your teacher wants you to do it.